Hi everyone, welcome to Integral Calculus. Today we explore lesson 9.3, Separable Differential Equations. Number 1, definition. A first order differential equation of the form dy over dx equal gx times hy is said to be separable. This type of differential equation is the simplest of all the differential equations because the solution can be found by integration. Let's take a look at some example. First set of example, solve the following differential equation. A, dy over dx equal y squared over e to the x plus e to the negative x. We can separate this out as dy over y squared equal to 1 over ex plus e to the negative x dx. Okay. Next step is integrate both sides. When we integrate the left side, we have y to the negative 1 over negative 1 plus c1. When we integrate the right side, we have it's a little tricky though. You cannot integrate right away. So this one is 1 over e to the x plus 1 over e to the x. We can do a little trick to simplify. So multiply by ex over e to the x. And here I can simplify this to be negative 1 over y plus c sub 1. On the right side, we have an integral of e to the x over ex squared plus 1 dx. Well, we can do the substitution here. Let u equal e to the x. So du is e to the x dx. And from here, well, we have a negative 1 over y plus c1 on one side. On the other side, integral of 1 over u squared plus 1 du. That is very familiar. The integral of 1 over u squared plus 1 du is arctangent u. Now, let's move the arrow up here. Negative 1 over y plus c1 is arctangent u. I'm going to replace it by ex plus c2. Okay. Well, we can move the c1 to the other side. And next time you only write one c. Negative 1 over y is arctan e to the x. Now, c2 minus c1 is just another constant. So I'm going to plus c. And from here, we can solve for y. So y would be negative 1 over arctangent e to the x plus c. Very nice. Okay. One more for this type problem. Dy over dx is equal to root of y plus y over root x plus x. Oh, it does look challenging though. Okay, so we have a dy over root y plus y equal dx over root x plus x. They're very similar, so we just have to integrate one side. And the other side would be pretty much the same. So let's take a look at the integration of the left side here. Here we can let u to be root y. Then y is u square, and du is 1/2 root y dy, meaning that dy is 2 root y du, and because root y is u, so it's 2u du is dy. Now we have integral 2u du over u plus u square. And this one, we can factor a u and simplify. So that would give us integral 2 over 1 plus u du. The integral of this is 2 ln absolute value of 1 plus u. We don't need to do the plus c1 because when we move to the side, it's going to be another constant. We know u is root y, so do the substitution. And we have 2 ln 1 plus root y equal to, the other side similar, 2 ln absolute value 1 plus root x plus, let's say, c3. The reason why I write c3 is because I can change c3 into another constant. Well, square root is positive, meaning we can drop out the absolute value. 2 ln 1 plus y root y equal 2 ln 1 plus root x plus c3. I can write that as 2 ln of c. 2 ln 1 plus root y. This would be 2, and then the sum of the 2 ln is the product law. Because ln c times 1 plus root x. Okay, divide both sides by 2, so we have a ln 1 plus root y is ln c 1 plus root x. Okay, 1 plus root y equals c times 1 plus root x. Root y is c times 1 plus root x minus 1. So y is c times 1 plus root x minus 1 square. Very nice. Okay, let's do more example. Here we have a solving the following differential equation given initial condition. Okay. E to the 2y minus y times cosine x times y prime equal e to the y times sine 2x given y of 0 equal to 0. Oh man, this is crazy, but we can do it. Move all the y to one side and all the x to the other side. So we have a e to the 2y minus y over e to the y dy is sine 2x over cosine x dx. Okay, let's simplify this before we integrate both sides. Simplify, then we have a e to the y minus y e to the negative y dy equal Sine 2x is 2 sine x cosine x over cosine x dx. So that will give us the 2 sine x dx. And on the other side, well, we can split this out into two different integral. So it's going to be e to the y dy minus y e to the negative y dy. And now integrate both sides. So integrate this and this. Okay, there's one of them that we have to do integration by part though. Integral of ey is the ey. There's no need to do plus c1, c2 because everything is going to be moving to one side. So you only need to do the plus c only one time. And then this integration by part here. So we can let u to be y, du is dy, dv is e to the negative y dy, and v is going to be a negative e to the negative y. Okay. So what we have is minus that. Be very careful with the negative positive side. uv, so negative y e to the negative y minus the integral of v du, so minus e to the negative y dy. Well, the integral of side is negative cosine, so negative 2 cosine x, and then plus only one c here. So ey minus minus is plus y e to the negative y, and then minus minus is plus you got to be careful which minus gonna be which one. When you distribute this in, you get a plus there, and then the minus of the minus is gonna turn into a positive. So that is why the integral is gonna be a plus e to the negative y equal minus 2 cosine x plus c. Okay, it is not possible to solve for y, so that is why we cannot have an explicit solution all the time. It's implicit solution. Well, now we're going to be using given initial condition to solve for c. Use initial condition. Y of 0 equal to 0. Use it, and we have a e to the 0 plus 0 e to the negative 0 plus e to the negative 0 equal negative 2 cosine of 0 plus c. Well, we have a 1 plus 1 is 2, and then this minus 2. Move it to the side, so I mean c equal 4. So once we have c equal 4, then the solution is e to the y plus y e to the negative y plus e to the negative y equal negative 2 cosine x plus 4. Okay, let's take a look at one more example. Now here comes the tricky one. In this one, we have y prime equal x plus y. We cannot write x plus y as the product of two function, one function in terms of x, the other one in terms of y. What can we do here? The trick here is let u to be x plus y. Then du over dx is 1 plus dy over dx. So this means dy over dx is du over dx minus 1. Do the tricky use up. And we have du over dx minus 1 equal u. Du over dx is u plus 1. So du over u plus 1 equal dx. Now integrate both sides. And we have ln of absolute value u plus 1 equal x plus c. Hit e at base to get rid of ln. E. Then we say that the absolute value of u plus 1 equal e to the x plus c. Well, e to the x plus c is positive, so we don't need the absolute value anymore. U plus 1 equal e to the x times e to the c. E to the constant c is just going to be another constant. So u plus 1 is c ex. Okay. And from here we see that we can replace u by x plus y. Sub it back. X plus y plus 1 equals cex, meaning that y is equal to ce to the x minus 1. We're going to be using the initial condition to get c. Use y0 equal 1. When we use y0 equal 1, then it's going to be a ce to the 0 minus 1 equal 1. So c minus 1 equal 1. C is equal to 2. And therefore, y is equal to 2e to the x minus 1 is the explicit solution. Because we can write y in terms of x. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel grow. I will see you in the next video.